Hello, and thank you everyone for joining today's webinar. I'm Jordan Sloop, your host from Kentik Marketing. Our topic for today is, what is network observability and why should you care? Our presenter is Kevin Woods, Director of Product Marketing. So in today's webinar, Kevin will review why network observability is the most important new concept to hit the network performance monitoring space in years. And he'll also discuss the term's origin, how to relate it to APM and DevOps, and what you need to do to make it work for you. So during the webinar, if you have any questions, feel free to enter them in the Zoom chat. We will answer them, as many as we can, in the open Q&A session at the end of the presentation. So with that, I'll pass it over to you, Kevin.
Thanks, Jordan. Let's dive in. So we'll talk about network observability, what it is, a little bit about the technology and what the difference is for monitoring. And then the second half of this webinar, I will actually go into the product and show you a little bit about what a network observability solution looks like. So network observability is definitely a thing. If you do a Google search, you'll see a lot of different vendor solutions talking about network observability. This is an image search that I did. You can see that people are talking about this in the industry, across the industry now. Let's talk about what our definition of network observability is. And you may know Kentik as the network observability company. So it's something that we talk about a lot. For us, we like this simple definition of network observability, which is it's the ability to answer any question about your network. And you can see what some of these types of questions are. They may be things that we know about ahead of time, like what are egress costs, or they may be things that are unknown, like why is the traffic hairpinning? They may be things that, questions that we have about the performance of our own network, or they may be questions about things that are coming from outside of our network, like are we under attack, or why is the network slow through a particular internet service provider? So in a network observability solution, and the way that that solution is built, as we'll discuss, it really gives you the ability to answer these questions, both things that you can predict, as well as things answering questions about things that you can't predict. So this is sort of a depiction about how to imagine what a network observability system looks like at a high level, what that solution does. So from sort of left to right here, on the left, you have the solution that's taking in data, ingesting telemetry data, and organizing and correlating that telemetry data that can be coming from devices or different parts of the network, the core, the edge, the cloud, could be correlating orchestration information from containers, could be information that comes from outside your network, from the internet. That can be a lot of different flow types or data types. So streaming data, SNMP, net flow, VPC flow logs, metric data from synthetic tests, all of those different types of telemetry. And then you want to take all of that telemetry data, you want to combine it in a data store, and you want to organize it, sort it, identify time series data, identify dimensions, be able to organize that to perform different workflows. So this data platform, which is what is shown in the middle here, needs to be scalable. It needs to be fast. It needs to be able to be easily accessible from different workflows or from different solutions. A SaaS-based solution is probably the best adapted for this, and is the way that a lot of people like to work with the solution anyways. Over on the right, we have the different types of outputs and different types of workflows. So we have dashboards, we have alerts, we have the ability to query the data within the data store to do sort of open-ended exploration, to zoom in, drill down, to create maps. And then down on the bottom right, we have the ability to take that telemetry data from the data store and export it to different systems, or to use it for messaging to ticketing systems, or for creating reports. And so altogether, this ingest, data store, and workflow functionality comprises what we think a good network observability solution looks like. Step back for a second and talk about observability in general, not network observability specifically, but the observability domain in general and where this term came from. This observability has really been used and defined in the DevOps space, in the application development space. Of course, it has origins in engineering long before that. And the idea of observability is it's the ability to understand the states or the status or the situation in a black box system. So the idea is that from the outputs of that system, or just from telemetry data that you can get external to that system, you can understand everything that's going on inside the system. And so, for a network, that would mean understanding network states, device status, traffic flows, who's accessing the network, events that change the network configuration, all of those sorts of things that you would be able to understand that just from telemetry data. And so we call a system like that observable, or that it's an observability solution. So that's a little different from monitoring, and here's how. I made this chart here. Monitoring is really about watching things or getting metrics on things that you know about ahead of time. So you're going to want to measure the utilization on certain links. You're going to want to watch the status of network access. There's a lot of things that you know ahead of time that you want to keep an eye on. But there are also events that occur with a network or with any system that you couldn't predict, and that you don't understand, and that you maybe weren't even measuring or looking at ahead of time. So an observability solution will give you the ability to go in and explore those types of situations, and to try to zoom in and organize your data or perform a workflow on your data so that you can find what is referred to as unknown unknowns, things that you don't understand and things that you could not have predicted. And this approach is more important than ever because our networks are more complex than ever. Our networks have never gotten simpler, and now they're more complex than they ever were. We have networks in cloud, networks on-prem, networks going to multiple locations. We have multiple service providers involved in our network. We have users accessing SaaS applications over the network. And so we need to really bring all of that information together to give us a complete understanding of what's going on. So in the DevOps space, the broad definition for observability is often this, which is logs, metrics, and distributed traces. You've probably heard that. And some add events to this. So you may hear, melt, metrics, events, logs, and traces. But, logs are oriented around information that's logged from applications. So the developers that write the applications will decide what sort of events or what sort of activity gets logged and what those transactions look like. Metrics are a measure, so it's usually a number. So patent number in networking, it would be number of packets or the percentage utilization of an interface or something like that. And so often these metrics are depicted in a time series. And distributed traces will trace the progress of an application or the interaction between different parts of an application so that software engineers, developers can diagnose problems with applications. Most of this is applicable to the network as well. Certainly we have, networking analogies for all of these things. Specifically, distributed traces, not so much, but we have other constructs in networking, for example, flows, which tell us about how traffic is going from point A to point B. And so that's an important component of network observability. But observability and network observability, the intersection of those two things is very important, and we're going to talk about that. So network observability is the ability to answer, any question about the network. And what do we mean by these questions? And I'm going to give you some examples coming up here. This is what a network observability system observes. It's all of the different components of your network, everything in your data center, all of the network in your cloud infrastructure, the network to and from your SaaS applications, your campuses, multiple campuses, the edge services that you consume, like CASB, DDoS services, security services that you may consume to protect your internal network in your organization from threats that come via the internet, or to improve the performance of internet access through things like CDNs or SASE, SD-WAN technologies such as that. All of these types of devices and all of these telemetry types, you want to combine that information, all of that telemetry information, in a network observability system to be able to answer the questions. And let's look at some examples of questions and why this is just not about single pane of glass, because single pane of glass we've been talking about for years. There have been different systems that help provide that. Network observability is certainly also about single pane of glass, but it's about a little bit more than that. And these questions will help illustrate that. So let's take an example of a telemetry type, which is traffic telemetry. Let's say this is NetFlow or SFlow or IPFix telemetry. We can answer questions like, who did this IP address talk to? What did it do? What did those destinations then do? Why is my bandwidth bill so high? What can I do to localize traffic? But with that telemetry, there are questions I cannot answer. Like, if there's a drop in traffic, is it due to an application, or is it another performance issue? Is the digital experience of my users being impacted with these traffic changes? What users or applications are consuming the network bandwidth? So we need other types of telemetry information to answer those questions. We'll come back to some of that. Another example, device telemetry, very important part of network observability. I can answer some of these questions. What are my interface level statistics now and historically? How much traffic is passing over each LSP? Is the device running out of memory? Is it overheating? Do I have a problem with the server or the computer? You can get some of that information from device telemetry, but you can't answer, why is the interface full? Are these interface errors causing performance problems? Or even, who are my top talkers in the network? We need other telemetry information to answer those questions. And now, to come full circle, let's look at synthetic testing, which is a popular way of testing network performance and growing in popularity these days. Synthetic testing can help me with a bunch of things. Are there specific links having packet loss or performance problems? What's the performance to specific endpoints or between data centers or clouds? Or what path is my traffic taking to reach a destination, and what's the performance of that path? But with synthetic testing alone, I can't answer where my user is impacted by a performance result, a bad performance, a bad link. Did a change in the network cause a performance problem? What is causing the problem? Were there other important customers or users or subscribers that were impacted by the issue? So the point of these questions, what you can answer and what you can't answer, is if I just had single pane of glass, I could answer a lot of these questions. But with network observability, because I can correlate different types of information together, synthetic information and traffic information, for example, I can ask a broader range and get answers to a broader range of questions. And that's the point of network observability. It's being able to answer as many questions as you need to answer about what's going on in your network. So let's talk about sort of the past and compare it with network observability a little bit here. So, we've had a lot of great solutions for network management, network monitoring over the years. A lot of these are often siloed into vendor-specific solutions, or they're siloed into specific sort of techniques. And network engineers know how to use each one of these systems and put all of that information together and answer, a lot of questions this way. And I think this is the past. Where we're going to with network observability is this ability to answer any question by using this different approach, which is I'm going to bring in telemetry and from all of my different sources, all of my different devices, into a network telemetry data store. Here you can see the streaming ETL pipeline that we do to achieve that. And then from that data store, I will serve different workflows, different tools, maybe Kentik tool, maybe another, to be able to correlate all of that information and give me the answers to the questions that I want. Another thing that's important here to keep in mind is that the data store can give me a lot of information about what's currently happening in my network, but it also gives me data retention. So I can look back and see, I'm being attacked. There's a botnet attack that I'm seeing. Have I seen this before? Has it, or I'm seeing an attack, or I'm seeing an issue, or I'm seeing a performance problem. When did this problem emerge? So it also brings the aspect of being able to look at history and use history to project trends and to better understand problems. So why should we care about any of this? Why does this matter? And why isn't this just a new spin on, what we've called network management for years and years? And I think this is really an important change that's occurring in our space right now, which is that application teams, DevOps teams, and networking teams are coming together, and they're more often expected to work together. Indeed, in some cases, we're seeing them organized into the same teams. We are seeing trends towards cloud, where the cloud infrastructure may be developed by application teams, but the network teams need to be involved as well. And so this convergence of DevOps and, let's say, NetOps requires that we sort of reframe the network management problem. And by looking at this from an observability perspective, I think it gives network engineers and network engineering a way to approach the discipline that is going to be much better understood and much more compatible with the way that application teams are working. And because the application and the digital experience is everything now, that really, really matters. And I think that's why everybody needs to care about this. So I am going to change gears now and just bring up the Kentik solution and show you what some of this would look like. So what we are looking at here is this is the Kentik portal. This is a demo environment. This is the Kentik product, but it's a demo environment. So the traffic that you see here is a lot of it's auto-generated, and it's not customer proprietary traffic or anything confidential. And this is an environment that we've developed that we use to demonstrate the product. So I'm going to show you a little bit about that now. And what I'll do is we go through this, and I'm just going to go around the product and show you some of its different capabilities. I'll explain how network observability makes a difference in the way some of these types of features work. So this is a landing page called Network Explorer. And if you go up to the menu here, you can see there's a lot of different places you can go in the product and a lot of different workflows. But this is a place where a lot of our customers land first, because this gives you an overview of all of the traffic in your network. And so you can see that here in this time series metrics. And then this does some breakouts for you, so you can go and see what your traffic is in different clouds where you have network presence. And then you can go down and look at a list of telemetry sources and traffic telemetry generators. You can sort those by applications, by devices, and you can see you have different ways of organizing that information here. If I were to click customize, I get a long list of different ways that I can, different dimensions, different facets that I can organize the display of that information by. And then over here on the right, we have different workflows that we can go into, all using the same data. We can perform synthetic testing, we can do capacity planning, estimate and project connectivity costs, look at peering, network peering opportunities, understand whether we're under attack, and look at DDoS defenses, look at CDN analytics, if we're a CDN provider, or CDN performance is important to our users or our customers, and OTT service tracking, so we can understand the application mix that's traversing our network. So we can go into these different workflows here. I am just going to use the menus to do that today. So what do network engineers often want to do first is understand the map. You know, what's my topology? What do I have in my network? How are things connected? And so this is a feature that we call a Kentik map. And this takes all of that network telemetry data, and it sorts it out and organizes it and creates a map for us. So we have here this is a version of the map that we have called weather map. You can see the locations. You can roll over those locations and get a little bit of health metrics. You can see green, yellow, reds. You can click on any one of these links and you can get metric data on traffic and a lot of different things here that you can see. Up above here, so that's our, this is our internal network or our on-prem network and its locations. Up above here, we have a menu for the different clouds that are connected, that we're connected to, or that our network traverses. And then all of the different origin networks, providers, or next hop networks that are connected to us via the internet. And so we can go in and we can click on these things and we can dive into any detail. I think an interesting one here is that I will click on Amazon, AWS, and I'm going to ask to look at the full map here. And so I'm zooming in here on the part of the network that is primarily within AWS, but I'm also seeing here how it's connected to my on-prem networks and how my origin networks or providers across the internet are connected as well. So I can go and select some of these things to understand more about that. I can connect an on-prem gateway, and I can see how the traffic flows from AWS and to AWS through that connection. I can see it's through a VPN connection here to a transit gateway. And then within each one of these gray boxes, I am seeing my AWS regions. And I can click on any of these VPCs in the regions. Oh, that's not a very interesting one. Let me click over here. And I can see some of the network topology and devices and gateways and types of connections that I have in my VPCs. And I can click on any of these to get details, understand the connectivity, look at the security policies, understand how traffic is flowing, and then go on up and see how that's flowing to anything else in my environment that I want to look at. I can click on any one of these links, any one of these traffic flows, and I can get traffic details here and sort that in different ways to understand what's going on with my traffic. So that is Kentik map. I'm going to go up into synthetics from the menu and look at agent map here to introduce you to Kentik synthetics. The way that synthetics works, it's a popular way now of measuring network performance as it pertains to the digital experience of my users or subscribers. And it works through a series of agents. These agents perform tests towards other agents or towards devices or services in the network to measure latency, throughput, jitter, other types of synthetic testing for transactions, web page loads, things of that nature. And here I can see in the map the Kentik global agent network and all of these other agents that are available. Private agents are specific to certain users, but I have global agents and app agents that are available to anybody that are in public cloud or public services that I can use to perform tests towards application servers or different infrastructure components to understand what the performance of my network is like for different types of users. Down below, I can see a list of all of the agents that are being used. Now, if I go up here to Test Control Center, I can see a whole list of the specific tests that I am performing, all the active tests that I am conducting to measure the performance of the network for my users. And these are different types of tests. I can filter them and sort them out if I want to look at a specific type of test. But here I can click, if I want to add a test, I can click on Add a Test. And here you can see the different types of tests that you can add. So there's network meshes and grids. Those are usually tests between a lot of different agents or cloud regions or sites. If I have a data center with multiple sites, or if I have something like SD-WAN, which could be a large distributed network for me, I can go in and test the performance across all of those different links. And I can see that easily in a mesh that we'll take a look at in a minute. Network and routing tests, BGP monitor, hostname tests are available, web tests, and API, HTTP page load tests give me a little bit more specific information about how my applications are performing and what my users may see. And these autonomous tests, ASN, this is a good example of where network observability comes in. So for example, I'm going to just select here to add an ASN test. And what the network observability platform will do is, because it can also see the traffic, it's going to rank these test potential rank the test potential for me by traffic levels. So I can look at inbound traffic level, or I could look at outbound traffic level to decide what is important to test. So I don't waste a lot of bandwidth or a lot of effort testing things that I don't need to test. Or I can just set up those tests manually. But the cool thing about network observability is I can set up those tests, and because my observability platform also sees the traffic, if my traffic flows change, I can automate the change of those tests. So the tests will configure themselves differently based on my traffic flows, and that's autonomous and can happen for me automatically, so I don't need to go in and manually babysit the system all the time and make sure that the tests are always being corrected. That's what network observability can do for you. I'm going to go into a different part of synthetics and just take a look at what we call the performance dashboard. And this is sort of a summary of performance from in a few different dimensions. These are free tests that are included with the Kentik platform. Popular one is this one right here, where I'm getting metrics. You can see test metrics on different SaaS application sites. And I can add any sites to this I want. Kentik comes pre-configured with a bunch of them that you see here. And because I can test these applications and these services from different locations in the world, I can get a really good overview here of what my users may be experiencing or what my subscribers may be experiencing in terms of digital performance. And I can see a problem here and maybe get ahead of a problem before my users actually notice by using alerts and insights. But this performance dashboard gives you SaaS application, cloud performance, BGP route information, and DNS performance for infrastructure. If I click on cloud performance here, I can see meshes of tests between agents that I have present in AWS or present in Azure in this case, and I can compare those. I can go in here and get sort of a summary of what my latency, packet loss, and jitter is for any one of those tests. I can click View Details to get the metrics laid out in a time series for me, so I can maybe see if there's a problem. Here's a jitter problem, right? I can see exactly where that occurred in a time series. And then I can flip that to a path view so that I can see time series here, path hops and geo distance laid out in a time series. And I can see the path that that test actually took. So I can see the nodes along that path. If I own the node or have access to it, I can get detailed SNMP metrics, or I can click on any of these links to get details about the test metrics, the test results of a trace route or a test that is used to measure this path. So this is a view that I can get for the path from any test to any tested target in the Kentik system. I'm going to go and show you something different, completely different. This is OTT service tracking, and this is from the same data set that is available to me for everything else you've seen. I am going in and using DNS information, ASN information, flow information, and data, and I am figuring out, the Kentik system is figuring out what the applications, different applications that are being used and how that traffic is flowing across my network. So you can see here, I can look at that by provider. So Netflix, this is a Kentik internal demo. So obviously there's a lot of Kentik traffic traversing this demo network, so on. And I can also look at those different types of traffic by category, video, gaming, and I can get as granular as I want here. I can go down and look at this traffic for individual users, but more often it's used just to take a look at overall traffic conditions and what my application mix is in my environment. This is not DPI, so there's no this isn't about getting packets and taking them apart. This is about using heuristic information and about source and destination information to figure out, what the source of the traffic really is and what who the OTT provider really is. And this is a much more efficient, cost-effective way to understand the traffic conditions inside my network. And let's see, next, last but not least, what if I just want to go and query the data on my own? So I'm going to go into Data Explorer. And last here thing I'll show you, this is sort of the raw, direct look into the data that I have, that I've gathered from my network. We have, I think, a simple time series here of top traffic, 95th percentile traffic traversing my entire environment by looking at all of the devices. But I can go in and I can modify these queries. Currently, I'm looking at all data sources, but I can go in and pick different ones. I can go in and select different dimensions that I may want to look at so that I don't have to write query language on my own. This is very easy to do. I just select the different dimensions that are available to me in my data. And I can do the same thing with metrics. So I can go and look at different types of metrics, measurements, synthetic test results, all of the different type of data that's gathered from my network and from my agents. And then I can sort that data, display that data in different types of charts and reports. And then I can go down here. We don't have a lot of devices right now being measured, but I can go down and get a list of all of the devices or all of the different facets of the way that I'm performing the query and looking at the traffic or looking at the test results. And what this gives me the ability to do is that if I don't have a workflow or I don't have a dashboard that seems to be giving me the information that I want, I can go in and do a direct query of the network telemetry data and explore to try to find what I need or maybe find the very specific source of a problem. And then it's very easy to go and create a dashboard out of that so I can monitor that, that attribute on an ongoing basis if I need to. So when you have a network observability data store in this manner, all of these different capabilities are available to you. And you can see different ways that the different types of data, the different facets of the data enrich each other and give you really a broad perspective and let you narrow down in on specifics about how your whole network environment is operating. So that is that. And in terms of the demo, just going to go down to one last concluding slide. And Jordan, can you see my slides? Am I showing that?
Yep, that's great.
Okay. So just in summary, network observability is the new trend in the network monitoring space. This is sort of a different way, a more modern way to gather all of your network telemetry data and to put it into a powerful data platform like we see in the DevOps space, like we see in the business intelligence space. And because this approach mirrors approaches that we see in adjacent spaces, this allows us to work more effectively with our colleagues in other parts of the business. We know that there's a big trend towards application importance, digital experience, application performance monitoring, and we want the practice to be able to work with those other teams, share information, import, ingest, export data between systems, and by making the network observable and organizing the network data in this manner, it gives us a way to do that. And it gives us a way to solve what is usually now our business's broader interest, which is, what is the digital experience of my users and how can I make that as cost effective as possible? Network observability, we believe, is the way to advance all of our efforts in that regard. So that's all I've got in terms of talking about what is network observability, why does it matter, and a demo of how a tour really is what I gave you of how the Kentik product works. I think we'll open it up for questions now.
Yeah, thanks, Kevin. That was an awesome presentation. A few questions came in via the chat, so let's open up the Q&A panel now. Let's see what we got. So the first question is, you mentioned network observability in DevOps systems. How would that work if there are two different platforms?
Okay, that's a good question. Yeah, and a common one. I didn't touch on this much in this presentation, but we have a product called Firehose that it exports data from our data platform in a big variety of formats and can be sent to or ingested by DevOps observability systems like Splunk or Datadog or Dynatrace. We have a relationship with New Relic, and we have specific interfaces for the New Relic One platform. So when you are in the New Relic platform and you're looking at network observability, you're looking at data that originated with Kentik. We have Firehose. We also have an open source aspect of Kentik, which you can find it's called Kentik Labs. They have their own website, and you can find out about different open source projects that allow you to use some of our agents, our open source agents like K-Translate, to export SNMP data, metrics, synthetics, test metrics to other systems if you want to use a hands-on approach and work with the code directly.
Awesome. So the next question is, how does your system deal with cardinality?
Yeah, back when I was showing the data pipeline and how that works, a lot of network data is highly cardinal. That just means that there's a lot of different values, and there's not so much consistency. IP addresses are always unique. Utilization metrics or SNMP metrics or whatever you're looking at in terms of metrics can have a wide variety of values. And so from a database standpoint, it's difficult to organize that through, let's say, indexing. Some of that can be done, but a lot of it, it's not practical. And so what Kentik has developed is a data store approach that allows us to search data that's highly cardinal and do it at a very high level of performance, so that your queries and your searches return results immediately, and you don't have to wait a long time. That's just a database skill that we have, and attribute of this type of system, working with highly cardinal data. So that's a little bit about how we do it.
Great. And the last question is, how are you different from Thousand Eyes?
Yeah, so remember we were asking questions about synthetic testing. So there's a set of questions that synthetic testing helps you answer, but there's also important questions related to that synthetic testing doesn't help you answer. So with a system like Kentik, we have a synthetic solution that can give you really good answers for questions about network performance. But we also have the flow information that can answer questions like, if I see a performance problem, is it affecting my users? Or based on the traffic that I'm seeing, what part of the network should be is probably the most important to test. Kentik helps you bring all of that data together into the solution, rather than just looking at network performance metrics standalone, where you wouldn't have as much context. So I think that would be the difference.
So it looks like we've come up on time. We at Kentik appreciate everyone for joining in today, and we've covered quite a bit of material. This webinar was recorded, so you can review a replay of it on our website, that is kentik.com, and please share it with your interested colleagues. In the next couple of days, you will get an email from me, so you can review the content, get a link to the recording, and get any additional information that you'd like. If you have further questions, please email us at webinars@kentik.com. Again, that's webinars@kentik.com. So thank you again for joining, and we hope to see you all again soon.